Alright, welcome to Accelerated Math Graph Absolute Value Equations. Alright, there's another one very similar to this, so don't think, if you watch the other one, think that you're watching the same exact one. This one has slightly different problems where you have to actually solve for y, so a little bit of difference here. But one thing that is the same is that we're going to use this learning card that we created in class, in my class, and it has graphing from a function. I want you to focus, and if you need to pause this on this so you can kind of take a look at this and understand what's going on. Basically, we're doing this part right here where we're focused on having an absolute value function in this format. I'll call it the vertex form of it, and it's with the a value out here, the x minus h, and the k value, so that you can easily identify the slope and the vertex of it. And basically what we're going to do is, once we identify those things, we're going to plot the vertex based on what we identify as h and k, and then we're going to use that slope to go down and over in this case because it was negative, or up and over in this case down here because it was positive. Now occasionally we're going to be missing an a value or an h or a k, and in those cases we're just going to add them in. The a value, if it's missing, it's just 1, and if the h is missing, it's going to be 0, and if the k is missing, it's going to be 0. So if you, like I said, if you needed to pause on that and jump back there or rewind, take a look at that, freeze the frame, you can do it. Alright, so let's take a look at this first one. Very simple example. It's got a in it, it's missing h, so we're going to just put it in there. I said we're going to put plus 0 in there, and then the k. So this one, the vertex is at 0, 5. Can I eliminate anybody? 0, 5. Yeah, I can eliminate this one because that's at 0, negative 5. And I can eliminate this for the same reason. Alright, so a nice little process of elimination. And the a value is 4. I said that was your slope. You're used to slope being in a fraction form because it tells you the rise over run. So you can just drop a 1 under there and you can see that it's up 4 over 1. So let's take a look at this one. This one's at the right vertex location. Is it up 1, 2, 3, 4, and over 1? Sure looks like it. And by the way, it would be up 4 and over 1 the other direction. So I believe this is it. Let's double check on this one. This one is not going up 4 and over 1, but it appears to be going down 4 and over 1 to throw you off there. Let's just double check, make sure there's no negative in front of this, because that's what the graph of this one is, as if there had been a negative in it. So, but it's not. So it's not that one. It's C. Alright, easy enough on that one. This one looks a little scary because it's got that fraction in the front, but that's no big deal. That's just the slope. It just means that it goes up 5 and over 6. So let's see, there's no h value, so we're going to throw that in there again. So we've got an h value of 0 and a k value of negative 2. So this one checks on the vertex. This one does not because it's up at 0, positive 2. This one doesn't because it's up at positive 2. Now we're going to have to really watch this. My eyesight, we need to make sure we're doing the up 5 and over 6. Alright, well, we don't have to watch too carefully because this one has a slope of going down, apparently down 5 and over 6. Let's just double check this one. Up 1, 2, 3, 4, 5 and over 1, 2, 3, 4, 5, 6. Yes, it lands back on there. And the other side is going to be an exact mirror image of this. It has symmetry across the y-axis. Alright, so C's it. Let's take a look at this next one. Alright, I left myself a little space up here because this one is not in that vertex form yet, so we need to get it in that vertex form. And I was kind of thinking about this one ahead of time. There's two ways to approach it. I think the easiest one is to, because this one is negative y on this side, I'm going to just watch what I do. I'm going to add y to both sides. So now I have 4 times the absolute value of x equals 3 plus y, or y plus 3. I'm going to subtract 3 from both sides, and I've got y over here, and 4 times the absolute value of x minus 3. Now I basically have it. I can, what is it, reflexive property or symmetrical property, symmetry property, I don't know. But anyway, I know I can, sorry for you math studs out there, but I can't quite remember what property I'm using here, but it's the, I guess I call it the common sense one. I can flip this thing over like this on an equation, and property of symmetry or something like that. So we've got a value of 4. There's no h in there, so I'm going to expand it to say plus 0. So I know my h is 0 and my k value is -3. So 0, -3, it's not that one, not that one. Those are up too high. These A and C check off. Let's look which one's going to go up 4 and over 1. Well, here it is, up 4 and over 1, so it's C. This one over here started at the right place, but it went down 4 and over 1, down 4 and over 1. So I thought that was the easiest way to do that. Okay, last one that I want to give you an example of. This one is clearly not in that absolute value vertex form, so we need to solve it for y. Here's what we're going to do. We're going to treat that 6 absolute value of x just like it's minus 6x. We're going to add that to both sides, and it's obviously not a like term with 5, so we get 5y equals 6 absolute value of x plus 5. You can see I'm trying to put it in that format. I'm going to divide both sides by 5. When I do that, I divide this entire thing by 5. Some of you like to see it that way. Some of you like to think of it as dividing each thing by 5. Either way it works. I mean, this is really what we're doing. These reduce to 1 or cancel out, as some people say, and we're left with 6/5 absolute value of x with no h value in there, so I'm going to throw this plus 0 in there and plus 1 out on the side because that 5 over 5 reduced to 1. Now I've got what I need. I've got a vertex at 0, 1, and I've got a slope of up 6 over 1. It's a positive slope, so I can identify, delete, reduce those answers out of there, and eliminate those answers. Then on this one I've got 0, 1, so it's in the right place, and let's just see, does it really go up 1, 2, 3, 4, 5, 6 and over 1, 2, 3, 4, 5? Yes, it does. It's this one that goes over both directions on this. What was wrong with this one? It was the vertex was down too low. It's at 0, -1 it appears, or -2. Well, that's kind of weird. Okay, so anyway, it was not that one. Alright, and that's it. Have fun. Talk to a teacher if you need some help.